Okay, but in this particular camera, the 40D, this is from several years ago now, and there are more modern cameras. This actually went up to an even higher ISO of 3200. And so while if you're using this compact camera and you set the ISO to 1600, and rest assured that it looks worse on the computer screen than it does here on the projector, just because the contrast has changed quite wildly. You might say, okay, well, using ISO 100 on this compact camera is actually quite acceptable because it's very clean, there's not a lot of noise, it's not harsh noise. But using 1600, you might quickly learn that you don't really want to use it all that much, because not only are you getting all this additional noise, but even if you look at this sort of actual example of a photo, you can see that it becomes a lot splotchier as the camera tries to combat that noise. So there's additional things going on as well, where the camera will try to reduce the amount of visible noise, and in doing that, it'll actually throw away some of the detail that exists in the photo. So you get this sort of blurrier, splotchier, uglier looking photo if it has very, very aggressive noise correction algorithms built into it. But you might then say that using an SLR, you could actually use higher ISOs a lot more acceptably within your photos. And generally, this actually may not be that big of a deal if you don't actually look at your photos, at their largest, at 100% on your computer screen, because then as you zoom out from the photo and make it look a little bit smaller, this sort of stuff averages out, and so you get less of the noise. But generally, you will really notice this when you zoom in all the way on your photo when you're trying to look at specific details within it. And so SLRs have pretty much always had better ISO sensitivity, or ISO noise characteristics rather, not the sensitivity, because as you can see, this is pretty standard. So ISO 100 across cameras is fairly standard. You know that ISO 100 from one camera, even across manufacturers, is pretty much the same. There's some minor variation, but it's pretty much the same from one camera to the next. And so despite that, what we look at is how the noise actually behaves at these various sensitivities. And so these digital SLRs, and this is what I was warning you about early on, if you don't have a digital SLR, you'll quickly realize why you might need one, quote unquote, in your arsenal of equipment. This is one of the reasons why SLRs have the upper hand against compact digital cameras. Now, it wouldn't really necessarily be fair, though, to use a modern compact digital camera. If you went out to Best Buy right now and bought a compact digital camera and compared it to a digital SLR that's maybe 5 or 6 years old, because the noise characteristics will be very different. Like I said, the technology matters quite a bit. You can really only compare against sort of technology from the same era, if that makes sense, even within the same manufacturer. But modern cameras can really get quite high in ISO. And so the Nikon D3, the Canon 5D Mark II, these are some of the more expensive digital SLRs that are available on the market today. But they don't just go up to ISO 1600 or 3200 or 6400. They don't even go up to 12,800, but they go all the way up to ISO 25,600. And so you can imagine that, okay, that's a lot of doubling. That's a lot of extra sensitivity that you can get there. And so just because these cameras are capable of it, however, as you can see from here, it doesn't necessarily mean that you should always use that particular ISO, because it will be, and this happens even for the SLRs. The higher up on the ISO chain you go, the more noise you're going to get. But you're getting a lot of additional sensitivity for you to get faster shutter speeds. And that means faster shutter speeds means that you can hand hold the camera without getting motion blur, for example, if you're indoors. It reduces your dependence on a tripod. It just makes it overall better because you have more options when trying to take a photograph. And so just to give you an idea, so like I said, every time you double the ISO, that's one additional stop that you can get in the shutter speed. So let's just say that I take, again, this photo at ISO 400, which is the ISO that it was taken at 1/1000th of a second. Now let's try increasing the ISO and see how fast of a shutter speed we can get. So ISO 800 means that I can get how fast? 1/2000. Okay, so that's only one stop difference. All right, so let's go to another stop. So now to ISO 1600. That's 2 stops. So now what's our shutter speed? 1/4000th of a second. So let's go another stop to 3200. What's my shutter speed? Yep, 1/8000th of a second. So now I have to, oh boy, this is getting hard now. So ISO 6400, and by the way, most digital SLRs won't actually let you go to a shutter speed faster than 1/8000th of a second. But let's say theoretically we could have a shutter speed that was this quick. We were now up to 1/16,000th of a second. And so you can see that even though it doesn't sound all that impressive that, oh yeah, sure, let's see, 25,000, an ISO of 25,600 is only 4 stops above ISO 1600. This is a lot because it's 2 times 2 times 2 times 2. You're getting a lot of additional shutter speed for what sounds like not very many stops. Yes?
Quick question, is there an ISO level that you limit yourself to? Is there a sensitivity that you decide you won't go above?
Is there an ISO limit that I will limit myself to? It depends. It's purely dependent on the camera and the noise characteristics of that camera. So on my 20D, which is now 5 years old, I'm really wary to go above ISO 1600. And even at ISO 1600, particularly in darker regions of the photo, you will see this sort of really obnoxious noise banding, it's called, where and so you can see some, and so it's not quite as bad as this noise, but what you will see is very patternized noise, and this isn't good because the noise will be sort of small and then it will increase suddenly, sort of like in a line, and then it will slowly decrease and then it will increase suddenly, in another line, and you'll just see these bands of noise through the image. And even if you zoom out, you still see these bands, and it's horrible. It's really bad. And so it really depends on the situation. I try not to go above ISO 400 or 800 if I really want to have a clean image, but only if it's very bright outside. So if it's bright outside, it's really hard to find noise even in a high ISO image. But once it gets darker, then you have to really start to limit yourself for the ISO. And so this is a really long non-answer, but really you have to look at your camera's noise characteristics and see how it behaves. So for example, like I was showing you before, in this camera, the 40D, as you can see, I mean, at least personally, I'd have no problem using ISO 1600. It's pretty clean images. There's really no obnoxious noise going on, but I'd be a lot more wary to use it in this compact digital camera where the noise is a lot more obnoxious and certainly much more in your face. So noise, for the most part, especially digital noise, is regarded as a bad thing. Most people don't like it, but a lot of people have this sort of nostalgia for film noise because it was very randomized. It just looked, that graininess that film has, people just sort of love the texture and the feel to it. And unfortunately, digital cameras just don't have that same sort of texture. It's harsher, it's more digital, for lack of a better word, partly because it is more patternized than the film noise that we see today. But just to show you a comparison, I do have a slide where we can compare ISO 1600 from film, so a film photo of someone's face from ISO 1600, to ISO 25600 of this Nikon D3 that's now, I don't know, now maybe at least a year old or at least several months old. And you can see that the noise between the two is actually relatively equal in terms of the quantity of noise. So you can see that, yeah, the film is quite grainy, but so is the Nikon. But you are getting 4 additional stops. And so there are still some holdouts, some people that say that, oh, film is still better than digital. Digital just can't match the resolution. It just can't match the noise characteristics. I think that's simply not true anymore. I think digital now is much cleaner in terms of the ISO noise than film was, especially at the higher ISOs. And nowadays, manufacturers are getting better about randomizing the noise, or removing this pattern, or this banding that I mentioned that existed. These more modern cameras just do not exhibit this problem as much. And so now we are at sort of this golden age of digital cameras where we have surpassed film, I think, and so we can now really freely use digital as a very good, high-quality medium for this very thing. But anyway, you can notice, so to comment specifically on the differences between the noise, you can see that the noise in the film is actually very fine, but it's also somewhat grainy. But some of the noise patterns that you'll notice on the digital is that we have these various hotspots. So for example, this big red dot that's here, and there's another few that exist on the image itself. Now, it's not a problem with this person's face, it's a problem actually with the way that this camera is reading the information. Just for some reason, it's adding some additional hot pixels, as they're called, where they're just much brighter than the surrounding pixels, and they're not supposed to be. Luckily, this stuff is pretty easily corrected, so you don't have to worry about it too much. The only time you'll see it is if you are really trying very, very hard to, and you turn off all of the noise reduction that exists in your camera. But now I think we can really feel free to crank up the ISO on a number of these cameras, except if you have a compact digital camera. Then you should pay attention to it and note its noise characteristics so that you know how it behaves. So as I mentioned before, changing the ISO now allows us some leeway with the shutter speed, so that we could increase the ISO, we could increase the sensitivity and get a faster shutter speed, as we mentioned before in that previous example with the raft, or we could try to decrease the ISO and get less sensitivity, but that means that we get a longer shutter speed. So that means we could decrease the ISO, get a longer shutter speed, and get some motion blur in here, for example. So if you want to get some star trails, for example, you might want to set a relatively low ISO so that you could have a long shutter speed, and the longer that shutter speed is open, the longer you'll be able to capture, say, Vega, the star that's highlighted in red there, and into your photo. But there is, as with all things, this trade-off. So, for example, you might take a photo first at ISO 800, and you might do it at that high of a sensitivity initially because you are standing outside on a dock and it is absolutely frigid and you want to go inside as quickly as possible, so you set a high ISO so you'll have a relatively fast shutter speed so you can go inside and call it a day. Okay, so on the left is the first attempt at ISO 800 at a shutter speed of, and yes, this was, it was dark, so it's a long shutter speed of 336 seconds. So that's about 6 minutes worth of shutter speed, and that's because that's because it's very dark outside, but it's also because of the final exposure value that we'll talk about shortly. But on the right, when I looked at this photo, I said, that's pretty and everything, but I have bumped up the ISO quite a bit. I could decrease it a little bit and have two things happen. I could decrease the amount of noise that exists in this image, and I can get a much longer star trail. And so just to solidify this concept of shutter speed, by decreasing the ISO now one stop to ISO 400, and that's the only change other than the shutter speed, which is now nearly doubled to about 846 seconds. So it's now 14 minutes long, which is about double the speed that it was before. So the reason that it's a little bit more is that the first time I took the photo, I noticed it was a little bit dark. So I not only wanted to double it, but also wanted to increase it just a little bit more so I could get a little bit more brightness into it. Now you'll notice that the star trail of the same star, Vega, is a little bit longer. It's actually double the length of the star trail here. Not only that, but the noise has also decreased by some considerable fashion as well. And so here, while ISO 800 isn't that bad, and note that we're zoomed in all the way on this photo, so you're seeing every single pixel, but even though it's not that bad, it's still noticeable, especially when compared to the cleaner, low ISO image. So if you want to take a photo like this, remember that many cameras have this sort of bulb mode where you can usually with a remote or just by hand push and hold the shutter down, and it'll keep the shutter open for as long as you're holding down the button. And so if it is, October, the end of October, and you are up in New Hampshire and it is cold and you do want to go inside, then it's usually better to have a remote so that you can just sort of flip the switch and lock it and then run inside, set a timer, and then come back out. But you don't have to, is the point, is that you can use this bulb mode in order to take photos very much like this. So there's this interplay between shutter speed and ISO. And as you can see, there's just like with many things in photography that we're just beginning to scratch the surface of, there's always this give and take there's always these compromises that we are presented with when we are taking a particular photo. Now, there are ways that reviewers in particular try to quantify the amount of noise when they want to show you quantitatively how much noise a particular camera has. So if you go to one site in particular, DP Review, digitalphotography.review.com, which has very, very comprehensive reviews, I think, and is a very good place to start if you're looking for a digital camera to purchase. One of the things that they do, and they seem to vary this sometimes based on the year and basically how they seem to feel about the camera, but they will sometimes graph the amount of noise that a particular camera has. And so in this case, this is a camera from the Canon, Canon A720IS, and I'm just using this as a representative example to show you how we can understand what this means. So what are we looking at here? Well, notice that we have along the x-axis, along the bottom, the ISO range. So we go from 100, apparently this camera has a lower ISO than 100 at ISO 80, but normally it starts at ISO 100 and it goes up in increments of about a third of a stop. So it goes from 100 to 125 to 160, so on and so forth, all the way up to the camera's maximum of 1600. And then it measures 3 different types of noise. So there's a yellow line here, a green line, and a red line. And each shows you a different type of noise. So part of the problem with digital is that there's different types of noise that tend to rear their ugly heads onto our photos. So the red line is what's called chroma noise. It's basically the variation in the color in a particular image. So if we were to go back a few steps, you'll notice that in this image here, not only does it seem to, the blacks not only seem to change brightness, where there's some spots that get a little bit grayer, but there's also some spots that change colors as well, so that there's some spots that are a little bit bluer or some spots that are a little bit redder. This is chroma noise because there's a variation in color, and that is what that red line indicates. However, these other lines basically tell you the difference in the brightness, or the luminance, in other words, of both black, this yellow line, so the variation of how much that black itself changes in terms of brightness, and the gray, so that green line. So if you're taking a look at some of this stuff, then this might actually be interesting for you when trying to pick apart some of these reviews and understand this quantitatively. And like I said, I think this is really only useful to compare against the noise against cameras of a similar generation, just because newer generations are almost always going to have better noise characteristics. There are some exceptions, but for the most part, that is generally true.